Today we're going to be talking about how to determine whether triangles are similar. So triangles are similar if they have all angles equal. So all of the angles have to be the same, and corresponding sides that are proportional, which would mean the same ratios. We'll look at that in a little bit. Okay, so we're going to look at three ways to find if two triangles are similar. Some of this may be familiar for you. Some may be a little bit different vocabulary. So the first way is angle, angle. We have side, angle, side, and side, side, side. And we'll write those out in just a little bit. So three ways to determine if triangles are similar. Angle, angle, side, and side, side, side. So let's look at angle, angle first. So AA stands for angle, angle, and means that the triangles have two of their angles equal. If two triangles have two of their angles equal, the triangles are similar. So let's look at this first example. These two are similar because if I have 72 here and 35 here, then I have 72 and 35 on the other. These would be similar triangles. You might also want to look at this and see that if you add these angles, 72 plus 35 is 107 degrees. We know that triangles have 180 degrees total, so if we subtract 180 minus 107, we know the third angle would be 73 degrees. So our third angle over here would also be 73 degrees, and those would be similar triangles. The next thing we're going to look at is side, angle, side. Side, angle, side stands for, or SAS, stands for side, angle, side. It means that we have two triangles where, number one, the ratio between two sides is the same as the ratio between another two sides. Okay, so we have two triangles where the ratio between two sides is the same as the ratio between another two sides. And secondly, the included angles are equal. I'll show you what that looks like in just a second. So if two triangles have two pairs of sides in the same ratio and the included angles are also equal, then the triangles are similar. So let's look at this example. Here we have two triangles, and we need to look at the pair of corresponding sides and the angle that is in between them. So if we look at one pair of sides, we'll start here, and let's look at 21. 21 is going to correspond with 14, so I'm going to draw a box around that. And 15 is going to correspond with 10. And that'll help me in just a second trying to figure out these ratios. So let's start with 21. 21, since it corresponds with 14, if I write that as a ratio, that could then reduce, if I divide both by 7, to 3/2, or 3 to 2. So the ratio reduces down to 3 to 2. If I look at the second set of corresponding sides, I have 15 that corresponded to 10. And I can reduce both of these by 5, and I get 3 to 2 as well. So the ratios are matching. They are proportional. And then we have an angle that is in between them that is 75 degrees. And that is the same. So there is enough information to tell us that the two triangles are similar. So we call this side, angle, side. We have corresponding sides that are proportional, and there is an angle included that is the same. And the last way that we're going to determine whether triangles are similar is side, side, side. And you should be familiar with this. This means that we have two triangles with all three pairs of corresponding sides in the same ratio. If two triangles have three pairs of sides in the same ratio, then the triangles are similar. So here's an example. So again, I'm going to circle my corresponding sides. AB is going to correspond to XY. BC, and I'll draw a triangle around that just to help me. BC is going to correspond to YZ, and 8, I'll box that one, corresponds to 10, or AC to XZ. So now I'm going to write the ratios. AB to XY is 4 to 5. And I don't need to reduce that. That's in simplest terms. BC is 6, and YZ was 7.5. Now, this is not as nice of a ratio here. We're going to have to do a little work to make sure that it reduces to the same. So I'm going to come over here and do a little bit of work. If I put 6 over 7.5, I can multiply this by 2. And 6 times 2 is 12, and 7.5 times 2 is 15. And so I can reduce both of those by 3, and that's 4/5. And my last pair of corresponding sides, AC is 8, and XZ is 10. 8 and 10. And I can reduce both of these by 2, and that gives me 4/5. These ratios are all equal, so the triangles are similar.